Yeah, I do think though that we should
All
let's
right.
make a little small talk.
Yeah,
Like
yeah. Well, we're live now.
okay.
Yep. So anyway,
So
yeah, it's been a few weeks now since our last stream, and hopefully we're going to be able to finish the light component now. But we'll see. Since one of the things we were just discussing is I opened it up after that time and realized that I had screwed something up, so we'll have to rework that. But
okay.
let's see. What other stuff is going on? Well,
Well,
there is certainly been a bunch of development on ephemeral stuff in the last like couple of months. I just put up a blog post with some of the new reproportion stuff, and maybe I should show it on stream a little later too.
yeah, and it's also worth mentioning that work is coming along in rig tools on actually getting this modular rigging into it.
Mm-hmm.
So I don't know. There's still a little bit of stuff, but we kind of figured out there was some kind of tricky drawing stuff involving Viewport 2 that I think we found a decent solution to, probably the best solution we're going to find at least. And so yeah, I'm pretty confident in saying that that it's going to come out in the reasonably near future. We're going to get out release 1.1, and it will have the modular rigging in it, and that'll be great.
Yeah. And we'll go from there. Eventually updating it with new components and different sorts of body plans and stuff. But I think what we want to do for the first one is just get a basic biped out, and then that's sort of the starting point for it.
Yeah, and I think for a lot of people, it's really probably kind of the missing piece of
Yeah.
rig tools, right? Like I think there are a lot of people who could benefit a lot from rig tools, but who really want something that's a little bit more like an auto rigger, right? They want to
Right.
be able to basically, you know, put a body plan in, resize it, do a small amount of weight painting because of course rig tools doesn't require that much, and have a working rig. And
Right.
I think that's going to be a big deal. I'm
Yeah.
excited
Yeah. I
about it.
think that it will. And actually, one of the things that we maybe should do shortly after that is that it would be pretty easy to do a body plan where that's using Contour to drive conventional joints, so that it's also game engine compatible.
That's a really excellent
Yeah,
idea for
and
sure.
that's
That's
actually given the framework we're building here, quite simple, right? It's just a matter of making an alternate body plan or alternate component depending on how you want to structure it, right? Where instead of just being like, oh, here's the joints and you use them, it's I attach some conventional joints to it and you bind to those instead.
Yeah, I think there's some interesting stuff that could be done too in terms of some of the adjustment stuff that
Mm-hmm.
you did, right? I think it's a little bit hard to do that purely as a component thing, but I think that some scripting could be done, some additional tools could be added that would allow you to do more of that adjustment stuff too. I do sometimes wish that we could work full time on rig tools. We
Yeah, that
obviously
would be there's a lot we could do actually.
right.
Um,
We have a lot going on between working on the ephemeral system as well, and the fact that all of us actually are still having to make a living because
right.
uh, we definitely, we've sold some copies of rig tools, but it's not able to support
Sure.
us entirely at this point, to put it rather mildly. So,
So
um,
yeah, I guess let's start out here. I think by saying I totally screwed this up when I did this last. Um, I basically, at our previous the previous session, I had drawn this set of bones that followed the leg, like the way you'd sort of imagine conventional joints, right? The problem with this is that Contour actually very much does not like situations in which you have 90 or near 90-degree bends in your set of joints. What you're actually supposed to kind of do for a leg is actually have overshoots, potentially in two directions. One direction is actually really all you need. Um, and I sort of followed on from that mistake by then doing an additional mistake, which was needing to align this control to the joint chain, which, given how this actually ought to work, is actually not necessary, as it turns out. So, yeah, let's fix that. Let's start out by fixing that and backtracking a little bit. Most of what we did, figuring out the IK and everything else, is still just as applicable as it ever was. In part because the whole system and the sense of how componentized rigging works is really resilient to these kinds of changes. So, for instance, one of the things, this whole guide orienter thing that I did in order to be able to get the guide sort of in the right in the right orientation isn't actually really necessary, probably. However, even if the guide is doing something drastically different, like pointing over here, all of this other stuff is still going to work perfectly well because everything has that live relationship in terms of getting the proportions of the rig to be live and to always respond to whatever it is that the guides are doing, regardless of what that is. So most of what we did basically can remain, but a whole bunch of this stuff involving this joint chain has got to change. And so let's start, I think, by changing that. So we had previously, the thing that we are going to have to recreate is there are, I think, a bunch of aims and stuff probably being used to, yeah, here we go, being used to get these joints to properly follow along with what the IK is doing. This stuff, the actual IK handle, will all be fine. But the stuff that we did, because we are going to replace this with a second chain, this is all going to have to change. So here's what I'm going to start by doing. I'm going to start by removing a whole bunch of this stuff that we actually don't want anymore. So let's see where I put it. Here's Contour IK Handle 1. See, this is a perfectly good case, right? Oh no, sorry, the IK handle is going to remain. It's the aim control that's going to change. Which is to say, I'm going to get rid of it. Let's see. Delete Contour aim handle. Well, that's unfortunate. Okay, well, we're going to have to look into that. However, the very first thing is I can just do this manually. Possibly the reason why that happened is that I locked a bunch of stuff. But we'll take a look at that.
Yeah, I'm actually getting I'm getting the stream very blurry. I don't know why, but I'm getting pretty poor video quality out of YouTube at the moment. And so I cannot read what's in your script editor, unfortunately.
Okay, well, I'm going to save it. I mean, we can recreate the situation rather easily. So we'll take a look at that afterwards. But in the meantime, I'm just going to go about deleting these things. That's a perfectly okay thing to do in this circumstance. Right, what am I saying? Would not be in the toe overshoot. It would be over here. This aim control also has to go away. And, of course, what it was supposed to do, which it did not do, which may be our bug, is to handle dealing with disconnecting all of this stuff, like the override blend and stuff. But we don't really need to care about that right now because we are actually going to remove these joints. Actually, before I do that, let me delete these orienters that get created because we also don't need them. All right. Should be able to. Yeah, there we go. Now we're back to more or less where I thought we were going to be, and we're going to add one in, which is now pointing way off in this direction where we don't want it to be. That is okay. Here's what we're going to do first. We're going to take the ankle guide outside of the guide orienter. So the whole deal with this guide orienter, which was a thing that I added in order to be able to maintain the guides being sort of tangent to the whole chain of the leg, the whole deal with the guide orienter, I think, is no longer necessary. Let me take this out from under it, and let me take away the aim constraint, because we no longer actually need to have this control aim at the next one in the chain if it's not attempting to actually maintain this as a single chain. This is the sort of thing where I'm like, I should have realized that that was the wrong thing to do instantaneously. Back, a month ago or whatever. No, it's not as much of a month now. A few weeks ago when I did that stream. But apparently, I don't know what was going on in my head. I did not realize that. And blithely continued to do something that would have been correct if we were trying to do that, but certainly isn't because we're not. So in this case, let's see what happens if I just zero this out. It's probably wrong. Yeah, it is wrong, of course. Because what we would want here is keeping in mind that for what we're doing with these components, X is always the direction. The X-axis is always the direction down the chain. So zeroing this is not actually correct. However, having it be its default be Let's see, put 90 in there. Apparently negative 90. That is basically correct. Let's just take a look at what values we're getting. No, it's not actually. We don't want to have anything here that says next joint orient is 180, right? So let's see. This one's pointing down X, but has Z pointing backwards. This one's pointing, yeah, that's what I thought was going on, but has Z pointing in the wrong direction. There we go. These should align nicely now. Yup, that is what I wanted to see. This is, of course, the values that I'm looking at here, these next joint orient values, are values that are being passed through from the from the guides through the component system where they become inputs, and are then, on the other side of like inside the component, arranged, put into, the matrices that we're receiving are used to calculate what these values, for instance, should be, like the next joint orient. That's how it becomes a live system where proportions are always adjustable. So now we have something that is actually set up to behave in a fairly appropriate way. Everything is sort of lining up as it should. And it's okay that this has, that the guide has values in its default. Because unlike, so here's an example. Now in this case, the guide's being fully controlled. Like it's just figuring out what its rotation should be. We did that a few sessions ago. But what we are actually seeing this guide do, is that its translation, for instance, is just some values, right? It's not zeroed in any way. And there's no reason, we don't need to zero the guides. Because they are not, the guides have no actual default state. The guides could be anywhere you need them to be. And the guides are what set the default state. So it's okay for them to have like rotation values or whatever they need to be in their default to, provide you a reasonable default value. And of course, we expect that users are going to be adjusting that. And in fact, one of the things we might want to do in this case is to take the ball and, let's see, here's the ball guide, which already has the toe attached to it. Maybe we want to put the ball guide under the ankle guide so that you can do this with the foot. That might be the best way to manipulate it, or maybe we'll decide that that shouldn't be the default. But either way, the whole system's resilient to stuff like that because we're relying on world space matrices. So let's give this a length that is appropriate. And this is actually something we're probably going to want to add an additional input, actually. And the reason why we're going to want an additional input is that where this overshoot ends matters. We could figure that out inside the component in some way, like say divide the length of the the lower leg by something in order to get a value for this. But you really want to be sure that the length of this thing is going to end. You don't want this going further than the bottom of the foot, whatever that may be, right? We don't know what your character's proportions are. We don't know like whether your foot is flat to the ground or not. It easily could be not flat to the ground, and we don't want to make that assumption. So it may be that we want to make that an explicit input. But I'm not going to deal with that just yet. Here's what we are going to do. We are going to draw some additional bones. And let's start. There's a number of ways you could conceivably do this. I think the best way, in terms of making sure that everything that this leg needs to do can be inferred from the guides. Well, though, it depends. You could have a very, very tall limb, conceivably. Right? For the componentized systems I've done previously, which really weren't intended to be this general, right? It wasn't like, oh, just throw the guides around wherever. It was like, oh, you might have to go and adjust the position of things like this, and that would be fine if you are, an experienced rigger. And a lot of these systems are systems that I'm mostly expecting to use myself. In this case, we want to make really sure that users are not going to be confused by this. So let me think about this for a second, because one of the natural things you could do in order to figure out what this second chain is going to be doing is just saying, oh, this one's going to be back up here. Because well, we know exactly where that is. We don't need to infer anything special in order to figure out where it is. But imagine you had a scenario where you had a character with a very, very tall foot, right? Something like that. We don't know what your character's proportions are. Maybe you could have a character with like a ridiculously tall foot. In that case, you're starting to approach the case where this too is like at a 90-degree angle. So I think what I'm actually going to do is to actually add a separate. I'm going to go ahead and add that new input that I need in order to know where the bottom of the foot is, right now, so that we can use that to figure out what's the best position to put this in, internal to the component. Let's see. I'm going to call this foot bottom guide. I'm going to parent it also to the ankle. Its default position is going to be like, I don't know. It's actually probably somewhere over here, because the way that I have this placed, or the way that I have these guides placed, they're on the 0, 0, they're on the floor, right? But honestly, the concept of the floor doesn't really mean a whole lot here, right? Your character could have feet that are under the floor or above the floor or anything else, right? That's why we can't rely on that. So I'm going to say the bottom of your character's foot's probably like over here somewhere. And we're actually going to limit that to translate only on X, because that's the correct thing. We just want to say, what's the length of this thing, right? And we're going to add an additional input to our inputs. I haven't organized any of this stuff yet, so yeah, here we go. A bunch of this is just sort of like in various groups, not doing anything particularly obvious. And I do need to organize this next, I think, so I don't confuse myself. All right, let's see. Hip, knee, ankle, ball, toe overshoot. Actually, you know what? This is actually better. We've got a toe overshoot. That should be foot overshoot. Let's be consistent about this. And once again, because you can't add matrix attributes to the UI, we're going to have to do it not through the UI. And we really have no choice about that. Not goot overshoot. That would not be correct. Actually, let me just check how I'm doing this. I want to make sure I'm being consistent about how I name them. And of course, Maya lies to you constantly about how things are actually named. I'm going to do list adder user defined equals true, and that is going to tell me that I did in fact use Campbell case, which is what I thought I had done, because that's sort of the standard thing to do with Maya attributes. But I just wanted to be sure. It's always good to be consistent about these things. I think it's data type. No, probably because that's not actually what that's named. Probably it's that. Yeah, it is. Okay. Foot overshoot is now here. Let's hook it up to the foot overshoot guide. This doesn't, we don't really need to use our this one's so simple, I'm just going to do it in the node editor. Let's see, world matrix. That is what we need. Foot overshoot. There we go. All right, so now it's an input, and we can use it to do a variety of things, such as drive the length of this bone. Now, as you may recall, let me just see what I have up right now. As you may recall, I had written myself, well, I had cobbled together, and they only half worked, a bunch of little functions to help me set this up, because a bunch of the doing this manually is actually very frustrating. And I think here it is. Yep. So I'm going to use one of those. And in this case, what I'm doing is using, let's see, I think I had one specifically for driving contour. Yeah, drive contour bone. This is now all coming back to me. I ended up having to like mess around with this last time because, as I said, this is all cobbled together. Drive contour bone, right, matrix input, space input, target bone. That makes sense. All right, so in this case, we're going to do it like this. And we're going to start by selecting the input because, and again, this is a reminder, I have set myself up a few convenience functions. S1 just means first item in the selection. It's equivalent to pa.selected, well, or pm, depending on how you import PyML, dot selected, and then slicing for the, well, indexing for the first item in the selection list. So that's going to be foot overshoot. And it's in the space of the first item in the list again, ankle, and then it is driving the second item, and that means I have to actually select this bone. There we go. Now this controls the length. This is why I love having little convenience functions like that. It's like, it sucks when they don't work and then you have to like manually make them work. That's really obnoxious. But it's great when they do work and then you don't have to do a bunch of really obnoxious rewiring of stuff by hand. All right, let's take a look at this. I'm not going to name this just yet. Obviously, names are actually important when it comes to like bones and stuff. I had a whole rant earlier about why I don't think names are important when it comes to DG nodes, but they do really matter for DAG nodes. All right, so what I can do here is, and I'll worry about its orientation in a moment, but what I'm actually concerned about right now is its position. I'm just thinking about it for a second. Yeah, here's what I'm gonna do. Actually, this is something, because it is sort of a one-off, I will actually do with the node editor. So note that, oh, sorry, I wanted the bone, not the joint. Yeah, now I have them both selected. That's the one I wanted. We have this distance between. This is part of the whole thing that function I just ran sets up, where it's going to output into its length the distance between. We can just use half of that, right? We could use a mult double linear node and plug the distance in and multiply it by 0.5. 1 second. Got to check on something real quick. Yeah, I don't think I got to get back to that right now. Right, I need to grab the joint socket, and I'm going to drive its translate X. Now, I am here to a certain extent doing a few things here that are a little bit less, let's see, how do I put this? They're a little bit less perfectly dependent. No, that's a bad way of putting it, actually. They are wholly dependent on the inputs. Like, there's no way that this can change. If I change the inputs by changing the guides, the whole point is this is going to follow along, and it's going to follow along no matter what I do. Even if I were to change this guide, like, your foot was oriented for some reason, like maybe your character is more in a modeled in like a Da Vinci pose than a standard T-pose, that's fine too. This will all just keep working and it'll be fine. However, there's something I kind of don't love about having the this chain not actually be at the location of an input. But I do think in this particular case, it is actually the right thing to do. Because it would potentially produce issues if it always was. Like I said, I was talking about those issues with like super tall legs, like, or super tall feet. Like, you could have that issue. We're trying to create something that is going to work for like 99.99% of bipedal characters. So we have to consider things that I normally wouldn't actually care about that much, because I'd just be like, well, if that does come in, you just fix it. And one of the things about it, of course, is that in a componentized rigging context, doing something manually to fix that can persist even as you're adjusting the guides. So, but I don't want customers to have to necessarily think about that, right? Like, sort of the point here is that customers don't. So I do think this is the right thing to do, but I don't necessarily love it. I kind of dislike the necessity of doing that. That said, I think this is actually working fine now. Let me try this. So let me say I'm going to define this to always be at 90 degrees. So this is always pointing out like this. And then I'm going to drive the, these controls, well, what am I saying? These joints, right? To always fit to what these guides are doing. That does require that I do a bit of an aim here in a way that is not quite the same thing as stuff that I've done previously with a lot of these inputs. Because in a lot of cases, what I really want to do with the inputs is that I want to figure out where transforms need to be inside the component, depending wholly on DG nodes. So, for instance, in this case, right, or in the case of this joint, this bone, where I'm figuring out what the lengths inside the component have to be, depending wholly on the inputs. If we just graph that for a second, all of this work that I figure out from the inputs in order to figure out what space to put it in, which is not particularly complicated. I mean, it's just a matrix multiplication, but all of that is being figured out purely with DG nodes. And I much prefer to do that whenever it's a reasonable thing to do. When I'm aiming something at something else, and that's not something the guides themselves are doing, it's not something the inputs are doing, it's something that I want to do internally to the component, you could do that. I mean, we have quaternion nodes available. We could do some stuff with DG nodes to make that happen. But it's not necessarily like it adds some complexity, because that's not an easy thing to do purely through DG nodes in Maya. Ideally, I mean, you'd have like an AIM DG node. There isn't really that, though. You'd have to sort of like put some stuff together. And in this case, I don't know. I'm halfway tempted to actually do that because I dislike the thing I'm about to do quite a bit, right? It complicates things. And it complicates the division of like sort of the responsibility of things. Because what I would really like is for the inputs to have a very, very simple relationship with the joints and bones that they're controlling. But I don't think that's actually a viable thing to do in this case. Actually, I shouldn't say that. It's viable, but I don't want to, right? It adds complexity, and you always have to make trade-offs like this. How much do you want to add complexity in one place to save yourself complexity somewhere else? And I think in this case, adding an actual transform with an aim constraint to essentially figure this out is what I'm actually going to do. So here is what I'm going to do here in order to make that happen. Let me just take a look at this for a second. Well, all right. Before I do that, let me actually make it clear why that's necessary in the first place. So, if I were to, for instance, take this bone and drive it off of the ankle and foot inputs, let me just show you what would happen if I did that. So in this case, we want to, like, we're starting with the inputs. We are going to drive this bone, and we're going to drive this with the difference between the ankle no, sorry. We want the ball in the space of the ankle. So here's what we're getting, right? We are getting something that is the correct length, but is not the correct, orientation. Actually, it's not even the correct length. Let me just take a look at that. I may have done something incorrect in that case. That seems odd. Oh, I'm sorry. The ankle's way up here. Right. It is actually the correct length. If I were to put this back up where the ankle is, you'd get the correct length coming down here. But that still means we need to get the orientation correct. And you know what this is making me think? Yeah, this often happens, right? I have decided that working too hard to accommodate tall feet is actually introducing complexity that I really don't want. Because now I'm realizing, not only is the orientation here something that we need to figure out internally to the component, but the length is different too, right? The length from this position to the ball of the foot and the length from the ankle to the ball of the foot are two different things. So we can, of course, figure that out. Like, we can do the math inside the component using some nodes, using some DG nodes to figure out what that is. But I really, really dislike it. It's starting to make things much more complicated than I want them to be. So I think I'm going to jettison that for the moment, because I really don't want to overcomplicate these systems. And I think the scenario in which you have a particularly tall foot is actually a fairly unusual one. A lot of this does honestly stem from the fact that we're dealing with math that has to be done through Maya's existing systems, right? If you were going to write this as a program that would just put the thing where you needed it to be, this actually really wouldn't be a big deal. But because you could like have a bunch of functions that would just sort of naturally do a bunch of the stuff that you need to make stuff like this work. And we don't, and that's not how Maya functions, and I kind of don't want to deal with it. I want this to be as simple as we can make it. So I'm going to get rid of this multiple linear. We don't need it anymore. Instead, what we could do is, I think, just zero this out. Yeah, that works. There we go. Yeah. Now, here's the next thing that we need. So the whole deal that we were doing with the ankle guide orienter, right, and that whole thing, was to be able to figure out the angle of what at the time we were doing with the guides from the ankle to the ball of the foot. We're not doing it with the guides anymore. I've now set up the guides to basically, the ankle guide to just sort of essentially be, always pointing downward. I mean, it doesn't always have to point downward. Like, you could choose to have it point somewhere other than downward. But generally speaking, I think that's actually more appropriate to the way that we're actually doing this setup now. So let me see how I want to go about doing this. I see how I want to go about doing it. This has to happen internally to the component. It's not something that we can do based on... It's not something we want the guides to be doing, because we want this separation where the guides are putting in just the information that they need and nothing else. So I don't want to introduce an extra guide or an extra input to handle this, because that is also introducing complexity that I don't want. It is, as they say, multiplying entities, right? It's like, now there's an additional input, but this input just sort of has to do this special thing that the guide has to do. So we have an extra one so that it can be oriented properly. That's really awful, and I don't want to do it. So instead, I'm going to do this. I'm going to say ankle orient buffer. And I'm because of the fact that the values that we're getting out of here need to not follow along with the character as the character's moving around with the scene. We need to, outside this hierarchy, like the joint hierarchy that we're actually going to be driving, outside this hierarchy, we need to basically be doing this aim constraint in outside the hierarchy, and that's actually very easy to do. Because what we can do here is, we can drive this one with the input for the ankle. So let me just take a look at my code for doing that and see what I need to call. I think we just need to use drive with matrix. That's right. Ah, Maya, what are you doing? All right, here we go. Actually, that was Windows' fault, I'm sure. Right, so let's get our inputs. Let's get this. We're going to be getting the ankle. And we're going to be getting the target is going to be the second item in the selection. I think this should do it. Yes. So now this is set to the canonical transformation of the... Come on, where are you? Yeah, see, this thing that Windows did still... Yeah, there we go. That's better. This is giving us the canonical base posed position of the ankle. Here's the really critical thing. That's not following along with the foot, right? If we move the foot around, this is still where the ankle was. So any math we derive from this is about the bind pose, not about the character's actual pose. This is actually a very, very important thing. So, oh, actually, before I do that, let me just note something here. Oh, no, that's actually working as intended. All right, just checking. So let's zero this out and call this ankle orient aim. Now, you could argue, and if this were in 2 dimensions, this would actually be super simple, and I wouldn't even choose to do it this way. That we know the location on the plane of which is currently all of these things are on the YZ plane. We know the location of the ankle. We know the location of the ball of the foot. Finding out the angle between those two things should be trivial. It isn't 2D. In 3D, it's actually kind of obnoxious. There's a bunch of ways of doing it. And I don't really want to implement it directly with Maya nodes, which is why I'm going through this trouble of using extra transforms and actually an aim constraint. Honestly, I think in some ways this isn't a good approach, but it is the approach I'm going to use. Let's do ankle orient target. And that one we're going to give to the ball of the foot. There we go. No. Oh, right, of course. That has to be in the space of the ankle if we want that to actually behave normally, because it's parented to this ankle orient buff. So let's try that again. We want it to be the ball of the foot in the space of the ankle. I actually think this is just the right thing already. No, it's not, because... Oh, because I was using the wrong... I was using drive contour bone, which obviously will not work in this circumstance. Let's just check this again. We want this to be matrix in space. Or rather... yeah, we can just pass that to drive with matrix. So here's how we're going to do it. So this will give us the correct matrix, and we're then going to drive the second item of our selection with it. And I believe this will give us... No, it did not. Possibly because I had the wrong thing selected or something. because I would imagine this would work. And it didn't. I did something wrong. 1 second. We're getting the ball in the space of the ankle, and we're driving S2, which is this current one, with that matrix. All right, obviously there was an error here, and I was covering it up. 1 second. Oh, it's saying I don't have a second item in the selection. All right. I think I did this rather incorrectly. Let's try this again. That looks more like it. No, it doesn't. It completely did not work. What did I do here? I did something dumb. Oh, this is our classic you actually changed the selection problem. Oh, I hate that. All right, here we go. Let's do it this way. Inputs target equals selection, and then we're going to change this here to actually use the variables. There we go. That's working now. Okay. Yeah, for anybody following along at home, right? What's going on there is that when Maya makes new nodes, it changes your selection. So if you have like a more complicated multi-stage thing that is using the selection and getting the selection in order to do its stuff, once you run one of those functions, your selection changes out from under you. And so I had to get the items first and then pass them in instead of being able to rely on the second item in my selection. And that's something that actually can be dealt with, like in the functions. You can just tell them to restore selection, but I have not actually done so. Right, so here's the target. Now we can get the actual value. And we are going to aim this, like we're going to aim X at it. Let's just see if this is, yeah, these are all oriented the way I would have expected. We do not want object up, we want none. We want the aim vector to be positive X. We want, I selected the wrong thing. Because target should not have an aim constraint. Target should be what is driving aim. Am I insane? What is going on here? I want the target to be the target of aim. You usually select them in that order. Yeah, there we go. I just got the selection order wrong. And this is giving us exactly the answer we'd expect. We have the x-axis pointing directly where we need it to go, and directly where this set of where this joint needs to be pointing. And in fact, now we can literally just take this aim, I believe this will work, and pipe its, let's see, we want the joint immediately before this one. So this is, no, that's actually not, absolutely not what we want. We want the joint immediately before this one. There we go. We want contour joint 5. I really should name these things, and I will get to that. And we are going to drive contour joint 5 here. Let's do it like this. We're just going to pipe. This is real like PyMel. Yeah, I'm actually going to do this in the node editor, or it's just going to be too confusing. I mean, it makes sense to me, but I type those things all the time. We basically want to take the rotation of this item and pipe it directly into the rotation of contour joint 3, which is incorrect. Why is that incorrect? Pointing down the x-axis. It's incorrect because we had already given this thing 90 degrees. It's adding an extra thing in there. That's what I wanted to see. Now, here's the really important aspect of this. Here's the reason why we had to do this whole rigmarole of like going around and creating this extra set of transforms so we could do the aim. Which again, I really kind of wish we could do this all with DG nodes, and in theory you certainly can, but I'm not going to. which is that as I move this thing around, it doesn't matter that I have oriented the actual control differently. Currently it's not actually, the orientation of the control is actually not affecting the joint, and that's because we haven't set up those aims yet. But it's basically the same idea. And the reason why it doesn't affect it is that we are essentially figuring out the math of how this aim ought to work using an aim constraint in a way that is completely disconnected from the actual relationships that the or I should say relationships would be the wrong word. The actual placement of these transforms when the character is posed. We're figuring out its canonical aim, not its actual aim. And that's how we can figure out from these guides what the orientation of this control needs to be in a way that won't produce any kind of double transformation or other issues when you actually go to use it in a shot. Hopefully that was clear. I mean, this is the sort of thing that sometimes, you know, and some people who watch this stream probably this is like, oh yeah, obviously you would do that, and some people are probably real confused right now. And I don't know, what do you think about that, Tagore? Was my explanation completely impenetrable?
I mean, I didn't find it completely impenetrable, but I have some experience listening to you explain things. So
okay, well maybe that helps. But yeah, this is part of, although certainly not the only reason, because this isn't the only way that you could set this up, right? This is sort of what we're doing to make componentization possible. If you're rigging by hand, you don't have to do this, right? That sort of thing. Although it helps to understand how it works. But 1 second, I do have to respond to something. Yeah, 1 second. Like I said, you know, I have a job at TTF. Sometimes I have to respond to things, even when I'm streaming. All right. Where were we? So actually, here is I immediately see something I actually want to fix, which has to do with which one of these items is being oriented. It actually should not be the joint, because we're going to add an aim handle to the joint. It should be the joint socket. So let me break that connection. Zero that out. And then do the same thing with the joint socket. Actually, this time I am going to do it with by the command line. There we go. Right. All right. So, next thing to do. Let's do an actual aim handle. Well, okay. Next thing to do, figure out why this thing's at a 90-degree angle. That does not seem correct. We're not. Are we actually driving this? Oh yeah, we are currently driving it. I do see what's going on here. Right. Well, I think I do. Right, we're actually driving this incorrectly. Now that this thing has happened, this additional orientation. Here's what we need to do. We now need to know what the target is, i.e. the ball of the foot, in this new space of the aim, which is constantly getting recalculated, right? It's constantly coming in from the guides, which you know, kind of honestly, I don't love that we're doing it this way, but it is something that here we don't need to do this. That's too ugly. I won't accept it. Instead, here's what we're going to do. We are actually going to use DG nodes to figure out what the target is in the aim space, because that is what is the was what we actually need to drive this contour bone with. So let me just break all these connections, because what, did it not let me do that? There we go. No, that was just Maya being weird. Yeah, we need to zero these out, and we can use some of the code that I've already written to go about figuring out what the space of the ball is in the space of this orientation, right? In the space of this tilted, I guess, right, oriented bone, because that's what we need to know to figure out the next bone in the chain. And it works exactly like when we're doing it with the guides and the inputs. It's just that one of these things is not actually going to be an input, which is one of the nice things about using something that is very general in the way that some of these sort of like little sub-functions I've made are like super, super, super general. A lot of it ends up being like this. So I can say I want to know what the space... Let's see, let me get aim inputs, or inputs aim, and the bone I eventually want to drive, which is this one right here. Actually, let me just make sure. It'll probably override anyway, but I'm just going to break the connections here too. So where were we? Inputs, aim, bone. So let's do it like this. I'm going to destructure that into 3 variables from my selection. Once I have them, this is to get around that obnoxious situation where Maya will constantly change the selections on you every time you create something. What is this? Set matrix something or other. Right, matrix, let's see. Drive with matrix, that's the one that we want. And we are going to send it to, or the thing that we are driving, right? You know, the thing that we are giving it to drive with, is going to be the result of matrix and space. And the 2 matrix inputs we are giving it are, the input matrix is going to be inputs dot ball, but the space that we're putting it into is actually going to be aim dot world matrix, because again, these don't have to be inputs. They can be, these functions are pretty general. They can be whatever. That's the matrix we're setting it to. And then the thing that we are setting is the bone. Oh wait, no, of course it's not matrix in space. It's what is it? Drive contour bone, or whatever it is I set this thing to. Yeah, drive contour bone. And that's input matrix. Oh, it actually does the whole thing, right? It's input matrix. I had apparently forgotten how this works. See, input matrix is inputs dot ball. Space input is aim dot world matrix, and it's the first one because that's always an array, and the thing that we are controlling is going to be the bone. Let's see if this works. think it may have. Because it doesn't seem to be doing anything egregiously wrong. Yeah, look at that. It's doing what it should based on moving those guides around. Now here's where the fact that the aim we have here, that we're figuring this out in 3D, using a constraint, which again, like maybe I'm going to replace that, but for now that's what we're doing, is that it is 3-dimensional, right? The math for figuring out this angle is extremely easy in 2 dimensions, and it's a lot less easy in 3. We're getting the aim constraint to do it for us, which I don't love, but I'm going to live with it for now. And the reason why I don't love it is it makes all these extra transforms. I really don't like that, but I also feel like I don't want to go figuring out, you know, an aim at using Maya math nodes right now. Maybe it'll bug me. Maybe it bugs me enough that I will eventually, but I'm not going to do it right this second. All right. So this is good. This should all work. We can sort of test that by moving this around too. Oh, well, right. Obviously, I parented this. Let me unparent it. I'm not sure if that should actually be parented to the ankle or not, because you could very well want to just sort of like raise the ankle or do whatever you want with the ankle without moving the ball of the foot around. But this is in fact behaving just as one would expect. No, I actually am going to put it under there because I feel like it's useful to users to be able to do things like, oh, I want the feet splayed out, and it's very simple, you know, instead of like moving the thing over and trying to get its orientation proper and stuff like that. So I am going to actually keep it parented in this way. And the final thing we need to do is we also need to drive this one. So let's do this. Drive contour bone, inputs, toe. Pretty sure that's toe. Let's just take a look. I am looking at the wrong thing. Here we go. I'm really looking at the wrong thing. I'm trying to look at inputs. No, this is actually toe overshoot, which is fine. That's actually probably what it should be. So toe overshoot. That is camel case. No. Please type what I'm trying to type, keyboard. And we want it to be in the space of the ball of the foot. Oh, right. Here we actually are using selection. In the space of the ball of the foot, and bone is just going to be S2. The reason why I can use selection directly like this in this case is it's just one function. There aren't multiple levels to it to screw with Maya's selection state. So I can just do like this and run this. It'll probably be fine. Yeah, it will. All right, because as we can see, now the length of this thing is controlled by the inputs. All right. Well, that actually took an awful lot of our time simply recovering from, you know, my earlier blunder, which is unfortunate, but actually that's exactly the sort of thing that happens constantly if you are rigging things, which is that you will constantly make blunders and then have to recover from them. That is the nature of, well, it is the nature of programming, actually, which rigging is an example, right? You are almost guaranteed not to actually get it entirely right to begin with, and to have to backtrack and fix something. That's just the nature of dealing with systems that have complexity, that are where the behavior, the consequences of what you do, is not necessarily immediately obvious, in an intuitive way, which is true of all. You know, it's true of all programming, really, like for the most part, unless you're doing something really, really simple. You're probably going to miss something. And the nature of being effective at rigging, or programming in general, I think, has less to do with not making mistakes, because you're guaranteed to do so, than it is with how fast you recognize that you have made a mistake and how effectively you can recover from one. I don't know. Would you say that's true, Tagore?
Yeah, I mean, you're always going to make mistakes in your programming, right? I don't know, though. I mean, I don't know. It's an interesting question. One thing I will say about this is that I think when you look at the productivity gains that more experienced programmers have over less experienced programmers, it tends to be less a matter of writing more lines of code and more a matter of kind of like getting it right more often the first time.
Right.
Right. So there is that thing. I mean, it is good to get things right,
Yes.
but it takes experience to do it, and nobody does it all the time. And you absolutely do have to be willing. I mean, we've talked about this a lot, right?
Yeah.
Like one of the things that I have really seen that's a big problem in software development is people getting overly committed to a certain path and being unwilling to walk it back when it's clear that they've done something that's a little off. And then what happens is it gets so deeply embedded in a project that it just gets worse and worse and worse and harder to take out. And so that's a real problem too. So I don't know. I feel like it's a mix, but absolutely, I think it is really good to do things in such a way that you can change your mind as easily as possible.
Yes.
I mean, unfortunately, that can be
Right,
kind of
like
hard.
that just happens. I mean, we have spent a lot of time refactoring stuff in the ephemeral system, for instance, when we realized that what we wanted to do was not
Right. We made some mistakes.
yeah, we made some mistakes, right? Like that happens.
Some of which, I have been kicking myself about a little bit. Some of them I probably should have been experienced enough to know that they shouldn't have been that way. And I think at least part of what happened is, so first of all, I didn't completely understand what we were doing at the beginning because sort of like I was working on architecture, but you knew what you wanted to do. So that was part of it. And part of it was just the general the stop and start nature of the way that we've worked on it, right? Like working on it for a few weeks and then putting it aside for a couple of months. That happened a lot right at the beginning of doing it. So
sure, yeah, it very much did. It's happened periodically during that time too. I don't think I'm going to do it in this session because we've ended up spending so much time like recovering from my earlier, blunders. But the it is something that I would like to like to address some of the new ephemeral stuff pretty soon on a stream, maybe next stream, because I think we're getting real close to actually being fully done with the leg, which I think will end our sort of componentized rigging unit, as it were. Oh, Filippo Macchio says, is this ephemeral rigging? This is not ephemeral rigging, actually, what we are doing right now. What we are doing right now is using contour rig tools to do a componentized rig system. It's all very, there's a lot of words here, and they mean specific things, but it would be easy enough to be confused by them if you were not already steeped in, this very tiny world of, knowing what some of these conceptual, aspects of rigging are. I would really love to show some of the new stuff with the ephemeral system. I actually just put a blog post up about it. And, we'll get to that soon enough. But before we do that, I want to finish up.
I will say one more thing about that. And I'm sorry, because I'm kind of ranting now, which is more, but I feel like,
yeah, I know, that's my job.
That's your job. But you know how I love my Perlicisms, right?
Sure.
Alan Perlis's, his epigrams in programming. And one of them is everything should be written top down, except the first time.
Right.
And, that's part of that, which is that when you work bottom up, it is easier to change your mind about things because you're building things up. When you work top down, it's actually very difficult to do that. So yeah, that's all I wanted to say.
Chris Fran says, is there going to be a session bringing all the components together into a whole character rig? Yes, absolutely. I should say, I feel like this would be really incomplete if we didn't rig an actual character with it. And that's probably going to be next session, right? We could have started doing that this session, but then I had to fix all of these issues. So, that'll be next session. So we probably wouldn't actually get to showing, any of the new ephemeral stuff next session. But maybe the session afterwards. Or maybe it will go fast enough and that'll be part of next session. I don't know. But yes, absolutely. I think it's, definitely something we want to do. To, we're going to rig an actual character, and you're going to see, what came out of this whole componentized stuff, and using the actual body plan and having it actually do what it's supposed to do. Apparently, according to
I'll get rid of that.
Can we get rid of those guys? Wow, they really want us to find ourselves a hot girl here. No. Let's see if we can kick those guys.
Yeah, well, I kicked and reported.
Okay. Let's see. So
they will almost certainly be back with a different handle, though. This has been
probably
my experience.
Yeah,
this happened on my software stream too recently, and luckily nobody watches my software stream.
Yep.
Oh, there we go.
Yep, there it is. They're Oh, are they actually back? Oh, I thought I was just responding to Chris Fram saying no thanks, I'm here for the rigging. Um, no, I am actually not seeing any more of them. But anyway, so yeah, so I think the next thing we do want
Well,
to do,
I'm kicking and reporting them
yep, as they come up, yeah.
yeah.
Um, the next thing I do want to do for this is do the space switching. Once we do the space switching, other than making it flippable, which I kind of don't want to do, I almost don't want to do that on stream because it's really fiddly, you know. And we did it once. We did it, you know, and it worked. But that was like a whole session. I don't really want to do that on stream for the leg, so I'll do that part probably offline before our next session. But the other thing that we need to do, and this is sort of the next thing we need to do for the leg. The only thing other than making it mirrorable that we need to do for the leg in order to actually make it a usable finished rig is to do the space switching. So I think that may be the next thing actually. But actually, before we do that, there is one remaining thing that's actually pretty important, which is that you know, one of the nice things about Contour is that these joints can become you know, these joints can be are also controls, which makes things a lot easier to deal with, right? You know, that's sort of the question of how these joints function. You don't necessarily need a double layer of stuff all the time, and that's what we're doing here. But we are going to add a it's not very obvious right now that they are controls. Let's add a circle shape. So that when we use these with FK, it'll be a lot more obvious what's happening. Oh, right, I also got to name everything. I might do that off stream too, because I don't really feel like doing it right now. And the one that we're actually using is going to be the... Right, that's going to be... Oh, I think we maybe... Did we already add a shape to that? Because I see a circle. Maybe I already did. Oh yeah, I actually just did. Okay. So, yeah, I mean, when we turn the IK off... Ew, that's incorrect. Glad I checked. Oh, it's because it has a rotate value. Must have been testing this earlier. Then these joints simply become FK. And everything is working correctly, yep, when you have it in bind pose. All right. Yeah, let's figure out some space switching. So, in the case of the space switching, because otherwise it's really kind of a pain, I am actually just going to rely on something that I wrote a little while ago. Like, I feel like if I do this by hand, I mean, like, I would never do it by hand, right? Like, I would always use a script like this to do it. And the way that this script works, I do want to discuss real briefly, though, so at least it's not a complete black box. At least it's not completely like, oh, I did this completely different thing. Nobody's got the faintest idea what it is. I want to sort of discuss what it's doing. There's a couple of different ways to make space switchers. In the case of, they pretty much all, in the case of Maya, rely on parent constraints to actually produce the actual behavior. That's certainly not the only option. I mean, you don't need parent constraints to do it. You could use, I mean, you could do it purely through math nodes if you wanted to. You could do it with matrix nodes and actually, but it's a little difficult to make. You know, the ideal circumstance is you have multiple potential incoming matrices that are going to go to your buffer, and you choose one of them, like you know, a conditional. But you can't in Maya put matrices into a conditional. That's not a thing you can pass through your conditional node. And I mean, you could sort of like kind of roll it yourself in various ways. Using a constraint is often the path of least resistance in this case, even though it is kind of absurd, right, that we need a constraint to do this, because we're really choosing this in this case when you have a whole bunch of possible spaces. the way that I like to do it is not to make them blendable. So I kind of flirted for a while with the idea of like, oh, you could have, 0 to 1 values that are weight values for each one. This gets a real ugly when when you're working with it as an animator. And managing the transition, though obnoxious when it's a sudden transition, is actually less bad than trying to manage a blend when it comes to Space Switchers. Because that's how bad the experience of working with hierarchical rigs is. It's actually better not to blend, right? It's better to just switch, even if you have to manage the momentum over the switch kind of manually. It's better to do it that way. And of course, a lot of the time, even when I'm using a conventional rig, and a lot of the time I want to use an ephemeral rig, but even when I'm using a conventional rig, a lot of the time I am working on, certainly even if I'm going to spline in the end, I'm working with poses up until the very last moment when I can't avoid working with them anymore. Chris Fram asks, what about blending IKFK? Yeah, I don't like doing that. It's allowed in the rigs because I think it's something people do want, and there are reasons why they want it, but I absolutely hate that sort of thing, right? Like, I want it to switch on a frame, even though that's really painful to deal with in a conventional rigging context, because the managing the intermediate transitional state where you're going from IK to FK and you've got something that's like in the middle, and it might have some like kind of weird behavior, and how do you truly control that? You don't actually, it's not one or the other, it is the combination of the two, and therefore you don't really have any way of defining precisely what that motion even is. This is sort of the classic problem, and I've ranted about this many, many times, but this is the classic problem of having sort of multi-layered controls in a rig, where, if you have, and it's not just FKIK, FKIK blending is a pretty unfortunate example, but there's lots of others. Even your classic reverse foot rig has all of these consequences where, like, you can see the consequence right here, right? Like, I rotate the ball of the foot. Oh, it's actually not on IK right now. 1 second. There we go. I rotate the ball of the foot. Oh, right. I forgot to add the aims. Okay, I better do that soon. I'm still going to go ahead with the space switching. But then I will add the aims. That's why this isn't behaving properly. But anyway, the point is, this is moving the ankle of the character away from its actual ankle control, which is something that I really, really dislike. I do not think it should work that way, and it's the sort of thing that the ephemeral system completely avoids. But as long as you're using conventional rigging, this situation in which the actual position of the ankle is actually caused by the interrelationship of multiple controls, all with their own motion, that needs to be considered both independently and in aggregate in how they cause the ankle to move around, is like evil. Like, I hate that. I think it makes animation really, really difficult. And so I feel the same way about FK-IK blending, right? If I'm forced to have a conventional rig with FK and IK normally, I want it to just switch, because at least I'm not dealing with this intermediate state where it's like being influenced by multiple things, and where any weird motion that I get out of that state is like, how do you even fix it, right? So yeah, no, I don't like to blend. But people do, and I even would, in a situation where a character's moving, say, very, very, very slowly, and it would be really difficult to maintain momentum properly on that switch. Again, this is what ephemeral rigging is for, in part. It's for getting around all of that crap. And I should say, and dealing with dense animation data is really a big part of that, right? In terms of like how it gets you around all of that stuff.
Yeah, the dense animation data is an idea that I think it takes a little while to understand how important it is, and how deep its implications are. But it just seems to me, I don't know, it just opens up a whole bunch of possibilities.
Yeah. It's like dealing so much. I don't know, this is my usual rant, right? But like, keyframes really killed flexibility in animation tools. They like really destroyed it, and it was a misstep from the very beginning. But anyway, let's do the space switching first, and then I'll go add the aims back in. Or maybe we won't even get to that this session. I may even just do that, because you saw me do the work to make that happen last session, even though I did it with, like, the old joints. It's not going to be any different. It's going to be exactly like that. So I might just do it offline, so that we can start right in next session with, like, actually making a character. But let's do the space switching. So, let's see. So what we are doing here is there's going to be a parent constraint. I mean, ultimately, this is what's getting created in this script, and the parent constraint is going to apply to the buffer of the control. And what that parent constraint is going to do, though, is all of its various like in a parent constraint, each input has a particular blend value and a weight value, which ends up resulting in your final stuff. Now, in this case, because we want it to just be a switch for space switching, the values can only ever be 0 or 1. We don't want a bunch of intermediate non-0 or 1 values in there, and only one of the values should ever be 1, right? And all the rest of them should be 0. And the simplest way to do that is actually with a condition node. So basically, you output... I mean, actually, you know what? Let me make one of these and then show you what it looks like in the graph, because I think that will actually be easier than me just trying to explain why we're doing it this way and how it works. And then it has to do a few other things, like make an enum attribute so that you have a little thing that you can switch on. But yeah, let me do this. Let me do this to begin with. So here's one of the things that we need. So in the foot buffer, for instance, or the foot, I mean, this will ultimately apply to the buffer. But I think we do it by selecting the foot. Let me just take a look at what that function takes for a moment. Target nodes, space nodes, enum names, rotation only. All right. I guess I got to make some space nodes to begin with, right? So let's actually do this. And this is actually going to involve adding some additional inputs. Actually, before I do anything else, let me clean this up a little bit. This is starting to get out of hand. These should all go in component. These should all go in guides. This was starting to just get ridiculous. Really, all I needed was a little bit of organization there, but I did need enough to like tell what's going on. It was starting to get out of hand. I will go back and name all the stuff and like organize it a little better, but what I mainly needed was to not have things all over the place. Right, so I'm going to make 2 nodes. One of them is going to be called character, and the other one is going to be called what spaces do I want this to have? One of them is definitely the character space, right? Yeah, I want character, I want upper body, and I want pelvis. I think are the spaces that you'd want for your leg. For your foot IK, right? And what I'm doing with these are all going to be driven by something. They're going to be in the components. They're going to be part of the component. But we're going to actually have to add some additional inputs here. So, you know this thing here where we have, I didn't even implement the anchor yet. Well, all right, so this is going to be very analogous to the anchor, and if we want to take a look at our reference here with the arm, you can see that the anchor, the anchor is basically like what you're using to be how you parent it to other parts of the rig, basically. So these spaces are very, very analogous to the anchor. I might as well go ahead and make the anchor node here. And I really spelled that wrong, didn't I? Yes. But these are all very similar concepts. So here's what we need. You may note for the arm, for instance, that if we look at the arm's inputs, we have an anchor and an anchor offset. And what that anchor offset means, we kind of went into this in one of the previous streams. What the anchor offset means is that you have a canonical position that you're parenting in, but you need to sort of zero it out, because you're going to be taking a bunch of stuff and parenting it to this transform, like this anchor transform or any of these space transforms. And we need those anchors or space transforms, either way. We need them to be in identity, meaning 0, 0, 0, translate, rotate, everything, in the bind pose. And so the offset tells us what we need to, the inverse matrix we need to make that happen. Because that way we can avoid double transformation. It's a method of avoiding double transformation. It's definitely not the only method available. But I think it's a pretty effective and comprehensible one. I do realize, and again, I'm never sure how much I am being comprehensible here, because thinking in matrices and thinking in the relationships in transforms is something that doesn't necessarily, like, it sort of does come naturally to the human mind once you're used to it, and once you're thinking about visualizing the relationship between matrices. But in a lot of cases, the reason why applications like Maya have tried to hide the fact that transforms are matrices and turn them into things like translate, rotate, scale values is because until you're used to it, it gets real hard to think about. And so I'm never totally sure. Like people tell me, like, am I just, let me know if I'm getting this across effectively at all. Because I'm never sure. But basically, a lot of this has to do with avoiding double transformation. Issues with matrices and what happens when you parent or like multiply one matrix by another, that's what parenting is a lot of the reasons why things like double transformation happen. And so essentially what this is all methods of avoiding that. So let's see. In all cases here, anchor, pelvis, upper body, character space, we need to have an input and an offset. Let's see what I did here. Yeah, because I only use the upper body space. You know what? If that's how we're doing the arm, if we're using the upper body space as like the space in question, we've got character, and the character space doesn't need an offset because the character is always supposed to be identity. Actually, come to think of it, oh no, you still need an input because of course the character could be moving around in the scene, but you don't need an offset because the character is always identity in bind pose. We only use upper body here for the hand, so we really only need, I think we're only going to use upper body for the legs too. So let me get rid of one of these. We don't need pelvis. But we do need, let's see, no, that's the other inputs. We need, right, add adder. We're going to call this anchor. Data type, I cannot spell, or type rather, equals matrix. Here's our anchor. We also need an anchor offset. And we have to do an upper body space and an upper body offset. Oh, that should actually be underscore offset. Pretty sure that's how I did it before, and I probably didn't do that for the anchor, and I gotta fix it. Yeah. Now you may say, why is this different from foot overshoot? The reason is that anchor offset is anchor, but the offset of anchor, whereas foot overshoot is what that node is. Like, there's no other like component to it. There's no other like extra thing about it. It's just, this is the foot offset, whereas this is the anchor's offset. The anchor is one specific concept, and then it is the offset of that thing, right? So I don't know. Like, you can use a variety of different naming schemes. You certainly don't have to adhere to this one, but it's what comes naturally to my head, so I often do that. So let's see. We have inputs. Body offset, right, okay. So this character, oh right, we need character too. So the character one is very, very simple. Here's all we need to make that happen. Where the... I swear I just added this, right? Oh, I see. It was only showing me the ones that were already connected. And we can put this... Oh, right. No, of course we do need a decompose node. I actually am going to do this with code because I don't feel like wiring that stuff up manually. Right. So now we are driving character with that, but again, we don't need an offset because the character's base, the base of the character, the thing you're going to move the whole character around with, it's always identity in bind pose. So we don't even need to care about that. That's just a rule that we sort of set up for ourselves in this particular system. However, when it comes to upper body, we need to do something a little more complicated. And this I am going to think, because I don't think I have any code to do this exact thing, so I am going to do this manually, actually. I'm going to make a mult matrix. This is sort of the inverse, almost, of what the matrix in space does. This is like, in a sense, space in matrix, right? Which is, we are going to take the upper body as the thing that we are transforming. Let's plug it into matrix in. And we're going to take the inverse of the upper body offset and plug it into... That is now getting multiplied. So here's what's happening here, basically. Right now, the upper body matrix is identity because nothing's being plugged into it. Like, it's just a matrix node. It's going to be identity by default, right? But it's going to end up being at some position, at some transformation in the scene. We need something that moves like that, i.e. is parented to it, right? Same concept, but which in this default pose, as defined by upper body offset, is always in identity. So this would be the equivalent of taking a transform that's at 0, 0, 0, and some other transform that's somewhere else on the scene, it doesn't matter, and parenting it, which means that that transform, that original one, which is at 0, 0, 0, would be multiplied by the inverse of this original, of the matrix of the transform it's being parented to, so that it can maintain its position. Now, in this case, we can simply take the inverse of the upper body offset, because we essentially want the equivalent of, what if you took an identity matrix and multiplied it by that inverse? Well, we don't really need to do that, because if it's identity, you'll just get the same thing out the other end. Just like, well, matrix multiplication is not really like actual multiplication, but it does have that in common, right? Take anything and multiply it by the identity matrix, and you'll get what you got originally. I'll have to test and make sure I did this in the right order. Pretty sure I did, but, it's always easy to screw it up, because that's just how matrices work. I'm not going to check right now because we're kind of running out of time. But I will have to check this before I actually try to use it. Let's see. Oh, right. Right. I need to decompose. Okay, let's do this again. In this case, I'm going to say matrix sum is the one I'm using, because that's what you get out of a mult matrix node. And that will set up the decompose for me. Ooh, I screwed this up. This shouldn't just be using output, rotate, and translate. It should be using scale and shear as well. Well, because, we would ideally want these rigs to be scalable. So this is probably a pervasive issue that I'm going to have to go back and fix. But it's not something I'm going to fix right now. Here's the important part. Well, again, we have this thing, this upper body is back at origin. And what we actually want to do here is to, like this is this temporary thing that I'm going to use to drive the upper body. I'm going to use this null, and I'm going to plug it into, this is what would be happening when we're in our body plan and we're like driving stuff. with other rigs, right? We're getting matrices out of those rigs, and we're using it. I'm just going to use this null to sort of simulate that. Which is that I'm going to... So I am actually checking to see if this actually works. It's probably the right thing to do. Because I couldn't resist, apparently. I'm just going to take its world inverse. No, not world inverse. It's world matrix. I'm going to plug it into upper body. And then I'm going to take its world inverse matrix, and keeping in mind that these would normally come from two different places, but they're going to match in bind pose. So for our test purposes, we're going to actually get them from the same place. Plug that into upper body offset. So what this should mean is that if I move this null around, I mean, nothing really obvious is going to happen because nothing's imperative to the upper body. I did, in fact, screw this up. This is incorrect, right? And well, now I figure out why it's incorrect. Oh, because like an idiot, I'm inverted. I shouldn't have taken that from the world inverse matrix. I should have just plugged it in from the world matrix, because we're inverting it on the other side. Inverting it twice does not get you the answer that you'd expect it would, right? That's what I expected to see. This upper body node, regardless of the fact that its inputs have been translated around a whole bunch, is still back at identity. I've canceled out the transformation, right? That's how this is supposed to work. And I should be able to do that regardless of translation and rotation. And if it doesn't, I'll probably know why, but in fact it does. If I were to scale it, this wouldn't work. And the reason why it won't work if I scale it is because, like an idiot, I did not actually hook this up properly in my code, and I'm only using rotate and translate. You really have to use scale and shear too. But like I said, I'm gonna fix that, but I'm not gonna fix it right this second. So the important thing here is that I've now verified that regardless of what other stuff I do, upper body's always identity in in the default pose, the bind pose of the character. Like this is sort of simulating what's going to happen in the actual body plan. So I can get rid of this. I just verified that it worked. What we want to parent to that is basically a bunch of things that are going to be, well, there's actually not all that much, at least to start with. Let's just use our foot. So we're just going to call this, foot space. Actually, no. Like I said before, it's foot space, because the foot is an entity, right? And this is the space of the foot, right? So I use an underscore for that. As opposed to upper body, where upper body is like one concept. And what we need to do there is to drive it with, so here's the thing, because it is a space in the upper body, we need that space to be driven by the inputs, just like everything else that contributes to this rig. And this is, again, sort of what the whole, like, inverted space thing here is to get rid of double transforms. It's because it makes this part a bit simpler, which is that we can take our inputs and our foot space and just directly connect them using drive with matrix. We can use S1 because we selected the input first, dot, ankle, actually. And it did not like that, and I probably did something dumb. Yes, because I selected them in the wrong order. Which probably means I should actually call this ankle space. Or actually, no, the correct thing is ankle upper body space. It's the space of the ankle in the upper body. And of course, this is now in the position of the ankle. So you know how when you're doing a constraint and you use maintain offset, this is we're basically doing that, but we're doing it manually. We're doing it adjustably. And it should be noted that theoretically, we don't really need to have these extra transforms. I mean, one way we could do this, and arguably this would be a bit simpler, is that we could make a constraint and actually drive the offsets of the constraint itself using the matrices that are coming out of and that's actually probably not a bad idea. I'm going to keep doing things this way because it makes it a little easier to see what's going on. But I actually have been fairly convinced that this is a little bit more complicated than it needs to be, and maybe I should do it the other way in the future. But like I said, I'm going to keep doing it this way for now. And we can actually just, to make the one that goes in the character space, we can actually do something, we can duplicate this, actually. Duplicate special, duplicate input connections, which means this is being driven exactly the same way, but, because again, all these things are identity and bind pose, this one is the character space. Okay. So these are our two spaces. And we're positioning them appropriately based on the inputs. So that they'll always be, we don't need to maintain offset, right? Again, we could potentially directly manipulate the offset inside the constraint using the same data, and it would have exactly the same result. And it would be a little less complicated. And again, I'm like, yeah, maybe I should have done that, but I didn't, and I don't want to do it now. And so therefore, we can go ahead and make this space switch appropriately. Here we go.
You're making Muppet sounds, my friend.
Yeah, I do that.
Mana.
I am sort of, in some sense, a Muppet. Right. Right, so make space switch. So I now have the matrix input is going to be, let me select inputs first. The matrix input is going to be inputs, oh no, I was looking completely. That doesn't need. That needs target node and stuff. It doesn't need to know the inputs. So the target node is the ankle. So this is the target node. The space nodes are going to be character space and upper body space. So that's S2, and I don't have an S3, so I'm just going to do it like this, which is the same thing. I know it says 2, but that's because it's 0 indexed. It's that's how it works. Oh, right, and that's got to be in some sort of tuple or something, because that's one argument that I'm handing it. Enum names. So now I need to say that it's the names are going to be character, and this is what's going to happen in the enum attribute. Upper body. Those are the two names. And rotation only. This is not rotation only, so I can sort of ignore that. Should just work. Unless, as has often happened when I've been doing this, it doesn't just work. And did this get hooked up properly? Looks like it did. Here's a space. We have two options, character and upper body. Now, right now, those options won't actually show anything different. But let's say, for hypothetical purposes of, figuring this out, I'm going to group upper body so that I can actually move it around independently. Note that if I now switch this back to character, it goes back to its original position. It's got two different spaces, and those spaces can now be, through these new inputs that I've created, driven by the by other components, right? In this case, this can be driven by the character component and the upper body. These are all independent components. They'll input their data through the inputs, and this allows us to have this sort of like bunch of potential space switches that you can stick stuff into. So that is about where I'm going to cut things off, because it's after 6:30, and I've got some other stuff that I need to get to. But thank you very much for coming. This one was a little scattershot because mostly I was just fixing an earlier mistake. Next time we are actually going to, however, be able to actually rig a character with this stuff. So I'm pretty excited about that. I will probably do a few things like making this reversible, in between those times myself, because, it is a lot faster to do stuff like that when you're not on a stream, and you guys saw me do it once already. So you can sort of imagine how those same concepts would apply to the leg. And then we will be able to, actually next time rig a character. So I will see you guys then at 5 p.m. on the whatever 7 days from now is. I guess that's the 17th, actually. Um, and please tell all your friends and like and subscribe. There's cool rigging stuff, and after we do that, we'll be back onto more ephemeral rigging, I think.
Yeah, that's exciting.
Yeah, that is exciting. The new ephemeral stuff I'm actually really excited about.
Yeah, it's neat stuff.
And yeah, we'll talk to you all then.
Yeah, thank you very much for coming by, and thank you, Raf.
Yep.
Bye bye.